Hello guys, this is Prashant, your strategy consultant, back on my channel Ahamevyaham. Today I bring you one more video in the emerging technology series where I'll be covering some of the real world or professional projects that I've undertaken in the past. Before we begin with the project, let me start with a short parable which is called as Knowing Where to Tap, also called a ship repairman story or the tradesman's parable. Once upon a time, it so happened that a particular huge ship had certain problems and nobody was able to resolve it. All the best engineers and naval architects, etc., were called. They studied, checked all regions and sections of the ship, and they couldn't resolve it. So finally, the ship owner get holds of a very old and senior guy, a ship repairman, who's famous for his expertise. So they call that guy. He looks around the ship, goes round and round for hours and hours, and then finally takes out a hammer from his jacket and taps on the engine in a particular location. And voila, the engine starts, the rudder is working, and the ship is fine. So everyone is happy, but when the guy submits the invoice, it reads use of a hammer $1 and knowing where to tap $999. So the bill is $1,000 and $999 are charged for knowing where to tap. So the ship owner asks him, what the hell is this? I've never seen this kind of bill. All you did was walk around the ship for hours and hours, and then you just gave a small tap with a hammer, and the problem has been resolved. So $1,000 just for a tap with a hammer? And to which the repairman or the tradesman replies that the answer lies in my invoice itself. Tapping with a hammer, anyone can do that, and the charges are just $1. But knowing exactly where to tap, that's the skill that I possess through my years of experience, and that's what is my expertise. So long story short, this is what a typical management consultant should also look at. Have a specific expertise about knowing where to tap, no matter who the client is, what industry or domain it is. So let's begin with today's video. So I've listed out some 4 or 5 projects that's on the screen right now. Those are the major projects that I've driven in the last 5 years. 2 of which are about digital transformation, one using blockchain technology, the other one using artificial intelligence and machine learning. There are 2 projects based on operational excellence. One involves the use of Six Sigma, the other one is about responsible sourcing, that is supply chain management, and one project is about life coaching. So today I'm going to cover the first one, that is the digital transformation project for one of my clients using blockchain. So here's the brief intro of the project. One of my clients' name is withheld for confidentiality reasons. I have signed an NDA with them. It's an engineering and maintenance company for a particular process plant, and the project is titled as DAP for real-time location tracking system using blockchain to reduce MTTR, that is mean time to repair, and TAT, turnaround time. Now the skills applied in this project can be divided into 2 sections, business and technical. The business part involves problem-solving techniques, design thinking, jobs to be done, and empathy mapping. The technical part covers NFC devices, that is near-field communication devices, and blockchain technology. So as you can see, this particular digital transformation project requires multiple skills which covers broad areas of operational excellence, product management, and emerging technologies. The duration of this project was 50 weeks, and the team size was almost 40 people, which included subject matter experts, field operators, product managers, business analysts, software engineers, system engineers, which included instrumentation and electronic technicians, and blockchain developers. I've divided this video into 3 sections. Number 1, beginning with the problem, trying to understand what the problem is. Second is the solution part, the solutioning part, and last but not the least is the forward part. So let's begin with it. Let me begin with a brief background on the client. CEM is an engineering and maintenance contractor to several energy companies, and CPP, that is the process plant, is one of their major clients. Now, this process plant receives gas nomination from a gas company and produces 97% to 99.5% pure methanol, almost 3,300 metric tons per annum, via state-of-the-art patented technology. It's patented technology by one of the global leaders, and they have their production facility, which is set up by which includes a state-of-the-art Japanese as well as German engineering in the Middle East region for their customers all over the world. Here's the problem statement. In the last 2 consecutive years, the process plant has witnessed process leaks of up to 8%, which amounts to almost $42 million per annum. That's a huge amount. Now, this is a cause of concern since process leak up to 5% is acceptable as per the industry, as per the process industry, specifically methanol. And they had achieved their best production in the year 2017. Now, the process loss has increased proportionally along with the increase in production, leading to decrease in their process optimization levels. That is, and which has also caused delayed production or lesser quality production. So, and at the plant level, around 12 to 20 permits per day are being issued. In general, 3 to 5 permits per day, which involves routine maintenance activities, is considered normal. 12 to 20 permits per day means there's a lot of breakdown that's happening in the plant on a daily basis. So that's the main issue of concern over here. So team was set up, a kind of study was done, and upon investigation, it has been observed that equipment failure and the resulting downtime is the major factor leading to increased process loss. The root cause analysis reveals that the MTTR, or the mean time to repair, is inconsistent due to delays in locating the right spares and tools for the breakdown equipment. We'll go into detail into this at a later stage. So the process plant has received several complaints regarding delayed shipment due to excessive lead times and quality issues, that is the purity of the methanol that is being produced, from their major customer. So the customer has stated that only limited orders will be placed with this particular process plant until the issue is resolved, and they have further communicated that future orders will be transferred to other 2 plants located elsewhere in case the reliability issue with this particular process plant continues. So this process plant has threatened the engineering and maintenance contractor to sever their contract due to their non-performance. So that's the core issue over here. There's a scope of loss of business, loss of goodwill, and a lot of other issues involved here. So you can see on the screen a very simplified analysis of the problem. What is actually happening in the plant? There are frequent breakdowns. Due to the frequent breakdowns, there is a kind of permit overload, because since there are frequent breakdowns, a lot of maintenance crew has to enter the process plant and do their repair work all the time, and obviously it's a huge process plant, so there's a permit to work system, so there's a permit overload. That is to say, instead of 3 to 4 permits per day, they are issuing 12 to 20 permits per day, which itself is an overload for the existing staff at the plant over there. And due to this overload of the permits, the repairs are delayed. And because of delayed repairs, because if the equipment is not back on time, there's going to be process loss. So it's like a dominoes effect, one thing leading to another. And because of the process loss, it leads to production loss as well as delayed production, and eventually they have an unhappy customer. Now, that's the problem in one simple flowchart. Now, the thing is, how are you going to try to solve the problem here? Now, just because there are frequent breakdowns, are you going to replace the equipment? The simple answer would be no, because replacing an equipment inside a huge process plant involves certain things called as management of change, which involves third-party expertise. It will also lead to increased capital expenditure as well as operational expenditure. So it's obviously not feasible to replace the faulty equipment. Now, in case of permit overload leading to delayed repairs, the simplest solution would be to penalize or change the existing contractor, or either change the system or the procedure. Now, both of these are going to increase your overheads. So again, that's a clear no-no. When it comes to investigating the process loss, one has to actually invest in research and development, which involves study of the entire plant design, the process design, detailed engineering, and all of these needs third-party experts, and this could be ongoing for several years. This is not an immediate kind of a solution. So obviously this is also a no-no here. And in case of in order to avoid the delayed supply or shipment or production loss, do we install increased storage? Methanol is stored in huge cylindrical tanks. So constructing those tanks or increasing the storage requires a lot of legal and statutory approvals. It poses a higher risk because it's a highly explosive material, and obviously there's increased capex and opex. So this also is a clear no-no. So where do we go from here? So let us try to evaluate the alternatives since you have analyzed the problem correctly. What I'm actually presenting is just a summary or gist of the entire exercise. In fact, the evaluation of the alternatives as well as the analysis of the problem itself took more than 3 months, because it's a really complex issue to study the ongoings of a process plant. So what you can see on the screen is a table below the flowchart. So let's look at each of the alternatives and analyze it as to how good or bad it is. So are you going to replace faulty equipment? The time could be as long as 3 years, because all of this, as I said, it's state-of-the-art plant, which involves Japanese technology as well as German engineering. So they will have to import a lot of equipment, and there's a lot of detailed engineering required. So it could be time-consuming. The cost of evaluation itself could go into hundreds of thousands of dollars, specifically $300,000 in this case for this particular plant. And what will be the end effect? The effect will be that before all the faulty equipment is replaced, they would still be incurring an ongoing loss of $126 million due to the process leaks, process loss, and the production delays. And there's additional capex and opex involved over here. And what's the end result? There is no definite estimate of the savings. So this is a clear-cut no-no from the management perspective. So what do we do next? Do we increase the support staff? Well, that can be done immediately within 2-3 months of time. More staff, more contractors could be hired on the site. There's no cost of evaluation involved over here, but it definitely involves additional opex for infinite period, because we don't know how much more staff we'll need, and we still don't have any estimate of the savings. And so what do we do next? Do we change the supplier or the contractor? Yes, this can also be done very quickly within 2-3 months of time, and the cost of evaluation will be minimal, because one will have to go for raising the request for proposal and analyzing the tenders, etc. So but that's still a minimal cost involved over there. But what's the effect over there? Again, this involves additional opex for infinite period, and there is no definite estimate of the savings. So what would be the next best option? Invest in research and development. Well, again, that's a far-fetched idea, because R&D can take pretty long, even up to 5 years, and the cost of evaluation itself would be $50,000. It will obviously involve additional capex and opex, because it needs involvement of third-party experts, and they would still be incurring ongoing loss of $210 million for the entire 5 years, and still you wouldn't have any estimate of the savings. So the last option would be to increase the storage this would be a face saving option, because increasing storage would mean you are maintaining more inventory on site, which poses higher risk. There are a lot of legal requirements. It will lead to additional cost of insurance, additional capex, opex, etc. And the cost of evaluation itself would be around $20,000, and the time to construct those additional storage tanks would be a minimum of 6 months. And at the end of the day, you still wouldn't have any estimate of the savings. So none of these options or alternatives are viable in this particular scenario. So let's have a relook at the problem and a brief overview of the existing system. As shown on the chart, the simple flow chart, there are frequent breakdowns happening, due to which there's a kind of permit overload which is leading to the delayed repairs and then goes on the dominoes effect. So let's look at the part which is ignored or taken for granted. Since there is permit overload, there are delayed repairs. So now what are the bottlenecks involved between these two stages? Let us analyze that. Number one, there's a high volume of assets and spares, more than 50,000 SKUs of stock keeping units, excluding consumables. So managing them, tracking them is a huge issue. Assets and tools are spread over 2 acres of land. That's the area of the entire plant, the process plant. And several spares cannot be barcoded due to their size, and some are even lookalikes. There's a lot of replication errors, issues and all, even in the inventory management software that they're having. And the standby equipment is available for major breakdowns, like an alternative compressor, an alternative pump and motor set, etc. But usually the use of the standby equipment will increase the cost of production. So you can't keep using the standby equipment all the time. And last but not the least, there are process delays and asset misplacement, which is fairly common, not just for this particular plant, every other process plant on the planet. There are process delays and asset misplacement that happens in every plant. Now that we have understood the bottlenecks, let us try to understand the practical on-ground difficulties that are being faced by the people there. On your screen you can see a typical layout of this particular process plant. And what can you see is, suppose there's a big breakdown in the CP10 section within the plant, and the repair crew has reached the plant. Now, and the permit to work has been issued for a particular repair job. Now the issue is they are supposed to collect all the tools and spares before entering the process plant and before reaching the site. So in a typical scenario, there's the central warehouse which would issue all the required tools, items and spares, and it says it has already issued those required stuff or items to the workshop. So the repair crew goes to the workshop. In the main workshop, they find that certain essential tools are missing. Now there are certain tools that are still held at the main security cabin at the main entrance of the area of the entire plant for inspection purposes, because it's a high risk zone where there are many requirements, many safety and regulatory requirements that need to be adhered to. One can't simply walk in with all or any kind of tool inside. So certain tools are there withheld at the main security cabin for inspection, so that to check whether they are meeting the requirements or not. For example, whether do have IP6 or IP7 grading, ingress protection, do they have any kind of protection or protective enclosures for use in explosive atmosphere, and so on and so forth. So what does the repair crew do now? And then there are certain tools that are left by the contractors from the previous shift in the contractors area, which is at another corner. So now this repair crew is confused, where to move around, where to search for the missing tools, and whether they should head straight away to the breakdown location, or they're supposed to keep running here and there in order to find all the tools before they reach the breakdown location. So this is the kind of issue which leads to delay, and this is just one simple issue that has been highlighted over here from a use case scenario point of view. Otherwise, there are n number of issues due to the permit overload, and which leads to the delayed repairs, and that has been listed out. What are the practical issues? Number one is the human error. Humans obviously tend to misplace equipment, tools and spares for various reasons. People who have gone to lunch might have forgotten their tools in some area. The people from the previous shift would not have returned the tools to the designated place. So those are the human error part. Then another thing to be noted is the plant is spread across 2 acres. So to move from the main security cabin to the breakdown location would take about half an hour if you're going by walk. A shorter time if you're going by a cycle, tricycle, golf cart, or some other vehicle. But that too in the summer season when the temperatures are like 40-45 degrees plus. So it's a very exhaustive work to move around within the plant area itself. Then they have the central warehouse. They have their own SAP plant maintenance and work control maintenance modules. But those are good for paperwork, accounting, and accountability. But they are not; those software systems are not going to help you trace the physical location of the tools. And there are 4 different workshops along with their store, so you wouldn't know which particular crew has carried which tool and left it at which place. And there are several critical packages in the process plant itself, ranging from CP1 to CP15 or so. And there are several specialized contractors. So there can be accessibility and ownership issues, that somebody might say that, oh, this particular tool set has been issued to contractor A, who has come for instrumentation work. Now, if a similar set of tools is needed by contractor B that has come for electrical work, there will be ownership and accessibility issues between the 2 different crews when there are limited resources. And issuing the permit to work and mobilization of the crew and the resources for repair work to the breakdown site is an issue, because physical traceability of the tools or the spares is difficult. People have to run around more than 24 macro locations, and when I'm talking about location, I'm talking about geographical physical locations within the plant. So for example, if a particular tool is kept at the main workshop, for example, the main workshop itself has its own in-house stores, and those in-house stores will have hundreds of bins. So I'm talking about the main workshop as one location. Even when you reach to that location, you'll have to keep searching for the tools in those several tens and hundreds of bins. So that's a huge logistical nightmare. Let's have a look at the solution now. How are you going to bring about the solutioning? That is shown in this simple smart chart in front of the screen. What is leading to very high MTTR or main time to repair? That is, the repair times are getting delayed and ever increasing with the frequent breakdowns. One is the human error, where people can misplace the tools and other items. Second is the logistical nightmare to trace the tools across the plant spread of 2 acres. And third is the accessibility and ownership issues as to who has issued the tool to whom and where it is actually required. So all of these things are contributing to a very high mean time to repair. So the proposed solution is to develop an asset tracker or a real-time location tracking system for all tools, spares, and critical assets. So here's the proposed solution: to develop Elfware tracker tags. What are these tags? It's basically a UWB or a ultra wideband transceiver over a private blockchain network with a decentralized app, DApp, for RLTS, that is real-time location tracking system. All possible plant assets, including spares, will be tagged along with the stacks, bins, storage, cabinets, toolboxes, etc. And each tag passively communicates using near-field communication devices or technology, its location to the other nearby tags. It's like a global P2P network within the plant limit. So an asset map is created accordingly and maintained and updated in real time within the plant battery limit. Any tagged asset can be traced instantly via the Elfware DApp. An alert is generated for any tag exiting the geofence, that is the plant battery limit, for any further action. And going forward, this Elfware DApp can be scaled up to Elfware DAO, or Decentralized Autonomous Organization, where the operations across multiple geographical locations can be managed using a GIS API or something like IOTA Tangle. Now, there's a precondition for this solution, that each item cannot have more than one tag, while a single tag can be applied to a bouquet of items. That is to say, you have a particular toolkit, say a megameter. A megameter is supposed to have only one UWB tag. It cannot have multiple tags. but your toolkit or the toolbox can have one tag which can contain several tools or items inside it. So that's one precondition. Second, there's a limitation that physical inspection is required at the point of entry or registration, where you're going to affix or change or swap the tag to a given item or equipment, as well as for removal of tags, that is deregistering the tag from your network. For in-use items, for example, spares. So suppose there's a particular spare that was tagged, issued, taken to the breakdown location, and it has been affixed to that particular critical package. Say for example, a particular IO card reader is being affixed on the main control panel. Now once it is affixed, the tag needs to be removed and deregistered, because then it's of no use, because it's in use in the plant, right? So that needs to be done, that's need to be taken care of. Now this is from the product management perspective. How does it look like or feel like or work like? On your screen you can see there's a thermal detection instrument. The tag can be embedded inside the instrument itself, or you can see a guy carrying a toolbox, so tag can be stuck to the toolbox like a sticker. Or there could be tags with ties which can be tied to your tools separately, which are visible. The tags are visible over there, and they can be swapped or changed as and when required. And the location of the tag, location of the particular required item can be traced using the Ahamevyaham asset tracker from your device. It could be a mobile device, a tablet, or your PC or laptop, where you need to enter at least two of the following: either the permit number and job zone, that is you can select from the drop down which area of the plant you're going to access, or the SKU number, the stock keeping unit number, where you can type the name of the tool and you can select what you're searching for, and then the result is going to be displayed with the tag number, the quantity of those items, and the possible the nearest locations of those items. And then you have a map below. You can click below to locate the actual physical location of that particular item, whether it is in a particular zone, in a particular store, in a particular bin. To that precise, you can get the results in the map itself, and the DApp is also going to give you certain alerts and messages based on the process requirement which is embedded in the smart contract. We'll cover that later on. And then certain technical specifications are listed on the right hand side. That is, what are we going to use? The software is the smart contract for asset tracking. The platform that we are using is Zilica, and the language used is Scala. The token that is being generated would be called as Ahamevyaham Asset Token. The DApp is Ahamevyaham RLTS, or Real Time Location Tracking System. DAO, if it is scaled in the future, would be called as Ahamevyaham Asset Management. And the front end can be built in React.js, SOAP UI, and other APIs. The hardware part here is the NFC device, that is the ultra wideband passive transceiver, or the tag. There are different makes and models, but the basic requirements are listed in the table below, where the accuracy is 1 meter to 10 centimeter. So that's the preciseness of the location that you can track your items with, and the range is up to 100 meters. So along with the tags throughout the plant, one needs to install the anchors or the readers which will catch the signal from the tags. The data transfer rate is up to 27 Mbps, so it's really fast, and that's the reason we can track the location in real time. Scalability is very high. The application is obviously localized and precise asset tracking, as mentioned earlier. And the security part is that these UWB tags have unique radio signatures which avoid multipath propagation. So there's no scope of interference from other signals and noises. And that's the reliability part, that there's no interference with the other RF signals, because a process plant typically has lots of sensors and other instruments located throughout. So this UWB tag is going to avoid all those interferences. And the functionality is that it transcends obstacles like walls and partitions too. So there's no receptivity issue within the plant battery limit. you can see on the screen the solutions architecture. Mind you, this is not the system or software architecture. This is just a solutions architecture from a very, very high level, where you have the Ahamevyaham blockchain operator, that is the engineering and maintenance company in this particular case, and you will have the zonal blockchain subscriber, which is the process plant in this case. So the blockchain operator is going to transfer tokens to the smart contract. There will be a main contract which will enforce the business logic or the requirements, in this case specifically location tracking in real time, and there can be subcontracts. So the main contract can interact with the subcontracts, which could have additional conditions like who's going to access it, who can view it, and all those access control and other business logic part can be in the subcontracts, where the process plant users can withdraw those tokens and perform those transactions over the blockchain. And obviously there will be anchors spread throughout the process plant, and there will be the UWB tags affixed onto all the required tools and assets, which will be transmitting. They will query for the location of the other tags and transmit their own location. So this way, all these queries will be pushed through this smart contract, and the smart contract will create those transactions, and which will be packed in blocks and added to the blockchain, which will give you, every block will give you the new location of the particular asset in question, and every user node can access this on the DApp on their devices. It's as simple and as easy to use as you can see on the screen. So here are the integration details from a very high level or a layman's perspective, in case if you're not technically inclined. So let me try to explain this further. Stage 1 would be accepting the items or the materials. Each identified asset will be affixed with a UWB tag at the point of entry, that is, say for example, the receiving bay at the process plant. Then you have to, stage 2 is you have to register the new or transformed item. So when a material is moved from one location to another location or integrated with other equipment, in this case for example there's item A and item B, certain things from item A and item B are picked up and integrated into a new toolbox which contains item A1, A2 and B1. So in such a case, the corresponding assets on the blockchain need to be updated or transformed accordingly. So for example, in a typical scenario, a pump package that was registered to the blockchain initially will leave the warehouse in say multiple lots, where with each subsequent moment of all those items or lots will be tracked separately. Then we can implement the concept of the process itself into a smart contract on the blockchain, and to counteract malicious processing, open source conditions will be defined, publicly enforced by the contract. For example, the calculation for a permit to work repair job at distillation plant. Let's take a typical use case scenario. Might be the OEM impeller shaft and backplate from the pump package, and dampers from the spare parts package. So the details of this calculation will be sent to the process contract once the transformation has taken place, and the identifier then encoded in the tag that will be passed with the transformed material down the chain. So once this has happened, we move on to stage 3, where one has to accept the transformed items. Just as inputs were transferred on the blockchain, when physically arriving at the plant, the outputs are transferred to the next actor in the blockchain when leaving the warehouse. So the Alpha DApp is connected to the UWB PBC network, that is the ultra wideband private blockchain network that enables physical asset management. So the tags self-update their precise location, and a reference to the digital asset is issued at the transformation step, which triggers the transfer of that asset to the next actor in the chain. And that is how the location of that asset is being tracked or is traceable in real time. So this is how it's actually going to work. And in case of one needs to remember that in case of an equipment breakdown, when the permit to work for repair job is issued, the on-site supervisor can immediately locate the required items, whether it is materials, tools, spares, etc., and mobilize the crew within minutes. And also missing items can be detected and the required indent raised immediately. Even the standby equipment can be located and changeover can be performed quickly. That's the beauty of this particular solution and the way it is being integrated. So how would the new system work? For you to be able to visualize it, I've displayed the factory layout once again here. Now with this new system in place, what would happen? As soon as the repair crew enters the plant or the site, they can directly go ahead to the breakdown location, that is CP10 in this case, and the support staff can bring them all the required tools along with the permit to work, or they themselves can split and get those items. The point to be noted here is that whether it is item A, B, item A1, A2, B1 or item C, they can check the location of those particular items on their DAP. Within seconds they will know the location, and then they can mobilize their team to collect those items even before reaching the breakdown site. So the delay at that site is reduced drastically. So what are the benefits of this solution? There's no scope of human error, because even if somebody forgets a tool somewhere, you can track it immediately. There's no logistical nightmare involved here, because you don't have to keep scurrying throughout different ends or corners of the plant in order to keep searching for the item. You know the precise location, so you can head straight towards that item in that direction. There is no accessibility or ownership issues also here, because along with the item and its location, if there are multiple items, those multiple locations are also being displayed in the DAP, and the physical traceability of the tools and spares is possible all the time, 24/7, 365 days a year. So this is going to reduce the MTTR drastically. On your screen you can see the project delivery KPIs. The overall project success was measured based on the completion time, that is, it was completed in 50 weeks as per the schedule. The blockchain network on premise has 100% availability, and the asset tracking has been 99.99% verified using the pilot project, of course. And what's the benefit to the client? That is the process plant. Earlier there was 0.72 metric tons per day loss, which amounted to $2,400 of loss per hour. That's when calculated the market price of methanol. And after the implementation of this particular project, the loss is only 0.36. That means $21 million saved per annum, and 50% of loss prevention has been achieved. Apart from the KPIs, let us have a look at the potential benefits. The benefit to the operator or the process plant. They can have their asset tracked in real time. Their mean time to repair and turnaround times are reduced drastically. There's reduction in average equipment downtime. There are many ratios and calculations. Their overall equipment efficiency has gone up, and many other factors are there. Apart from that, there's reduction in process loss and leaks. There is better in-house material requirements planning because of this. The quality of the methanol produced is more consistent, and eventually there's an on-time shipment. There's higher efficiency of the workforce. Assurance of confidentiality, integrity, and accountability is there, because no one can blame the other crew or the other team or other department that we don't know where the tools were and why there's a delay and etc. And there's zero shrinkage or pilferage. There's on-premise hosting of this particular standalone system due to security concern. Process plant can't put this up on the cloud, right? Going forward in the future, they can in fact do remote monitoring via a virtual private server or using a long-range WAN. And what's the benefit to the contractor, that is the engineering and maintenance co here? They can achieve greater customer satisfaction. Their operating cost has reduced due to less man hours required per job. and this is a kind of new product or service line that complements to their core business. And since the UWB tags are low cost and can be reused over the years, so there's difference between using RFID and UWB tags. The UWB tags are very, very cheap compared to RFIDs. So the Elfware tracker tags, the Elfware DAP, and if in the future if it is scaled into an Elfware DAO, can be used across all other operating principles or clients. So it opens up a new product line or new avenue for revenues in the future. So far so good. So let's have a look at what's the forward path. One must remember that whenever anyone takes up a digital transformation project, it's not about just problem and solution, or trying to solve something with immediate results. It needs to have some kind of consequences for the future too. That's why I'm covering forward path here. What can be done going forward is an analytics layer could be added on to the existing private blockchain network, where the transaction data can be etal, that is extracted, transformed and loaded from the private blockchain network onto a total analytics platform, based on which one can develop ML model to find patterns that can enable one to define the minimum stock levels, economic order quantities, minimum reorder levels, etc. for those stock items or critical spares. One can label the frequent breakdown zones for further and quicker action. They can evaluate the contractor performance over time. So all of these are the added benefits or the future projects that can be done based on this particular project. And going forward, the Elfware DAO plus the Elfware TAP can be a separate service offering to the clients worldwide, which can be called as operational technology as a service. So guys, I believe you have enjoyed watching this video and try to understand what I've presented here. It's not just a digital transformation project, but it is something that can really add value to your business, your clients, and yourself also. And when it comes to digital transformation projects, I'm telling this from a management consultant's perspective. Digital transformation projects typically require a cross-disciplinary team with expertise from different areas, and as I've mentioned, even as a management consultant, you need to have multitasking abilities and cross-functional leadership to manage a huge team and to oversee something which involves operational excellence, product management, and emerging technologies. So one can look forward to such projects with a lot of enthusiasm if you follow the steps that are absolutely required in solving the problem or the particular business case at hand, as I've described in this video. So keep watching and stay tuned. Ciao.